At 0730 hours on July 14, 1944, Sergeant Curtis Cullen stood beside a Sherman tank on a training ground near Colombiers in Normandy, watching as General Omar Bradley arrived to inspect a modification that likely violated nearly every regulation in the Army manual. The tank belonged to the 102nd Cavalry Reconnaissance Squadron. Cullen was 29 years old, a tanker from the New Jersey National Guard whose unit had been attached to multiple divisions fighting in the bocage. Welded to the front of the Sherman were 4 steel prongs cut from captured German beach obstacles. Bradley had driven out personally to determine whether this unauthorized field alteration could solve a problem that was killing American soldiers by the hundreds every single week. Cullen had been working on tanks in Normandy for 5 weeks. He understood armor thoroughly. The M4 Sherman was a dependable medium tank, adequately armed, mechanically reliable, and well suited for open terrain. But it had one fatal flaw that was getting American tank crews and infantrymen killed every day in the Norman bocage. It could not penetrate the hedgerows without exposing its vulnerable belly armor to German anti-tank fire. The hedgerows were earthen embankments averaging 4 feet high, topped with up to 15 feet of dense brush, trees, and interwoven root systems. They divided every field across the Norman countryside. Centuries of farming had produced a landscape perfectly designed for defense. Each hedge functioned as a natural fortress. German troops carved fighting positions directly into the banks, machine gun nests, anti-tank emplacements, sniper posts, all shielded from overhead artillery fire. American doctrine dictated that tanks should climb over the hedges to force a breakthrough. That was the training. That was what had worked during exercises in England. But the Norman hedgerows were different, thicker, taller, stronger. When a Sherman attempted to climb a hedge, the tank pitched upward at nearly a 45-degree angle. Its frontal armor pointed uselessly skyward while the thin belly armor faced directly toward German anti-tank guns concealed in the next hedgerow. The tank could not fire its main gun. The driver could not see ahead. For 5 or 6 seconds, the Sherman was completely defenseless. That brief exposure meant death. First Army had lost 231 tanks in June alone, most destroyed in the hedgerows. Infantry casualties were even worse. Between June 6 and July 31, rifle companies lost nearly 60% of their enlisted men and more than 68% of their officers. Entire companies were being ground down, advancing field by field through the bocage. Training manuals blamed poor tactics. Officers claimed tank commanders were failing to use proper avenues of approach. After-action reports cited inadequate reconnaissance, insufficient infantry support, and poor artillery coordination. But tank crews and mechanics on the ground knew better. The problem was not tactics, training, or coordination. The problem was the terrain itself and the way American armor was forced to confront it. The bocage was unlike any battlefield American forces had trained for. Exercise areas in England had hedgerows, but they were smaller, thinner, and far less formidable. British hedges were agricultural boundaries maintained for a few centuries. Norman hedgerows were ancient earthworks that had accumulated mass for 1,000 years or more, some dating back to medieval farming practices. Generation after generation of farmers had piled stones cleared from their fields onto the same boundaries, year after year, century after century. Trees had grown, died, and been replaced, their root systems intertwining into nearly impenetrable barriers. The soil and embankments had compacted into structures as solid as fortifications. The solution everyone kept attempting, using combat engineers to blast gaps in the hedges with explosives, was killing soldiers even faster than the climbing attempts. Engineers would approach a hedge, set charges, detonate them, and the blast would alert every German position within 1,000 yards. Artillery fire would begin falling before the first tank could advance. Machine gun fire swept the breach. Tanks that pushed through were immediately struck by pre-sighted anti-tank guns. Engineers attempting to place additional charges were cut down. Several units experimented with their own solutions in late June and early July. The 79th Infantry Division had a hedge cutter operating by July 5. 19th Corps demonstrated prongs originally intended for placing explosives. 5th Corps units developed devices nicknamed brush cutters and green dozers, but none spread widely. Most required specialized equipment or extensive modifications that field units could not easily replicate. The 102nd Cavalry Reconnaissance Squadron had been discussing the hedgerow problem for weeks. They were a New Jersey National Guard unit, the Essex Troop, with a lineage stretching back to the Revolutionary War. The squadron landed on Omaha Beach on D-Day +1 and had been in continuous combat since June 7. Unlike infantry divisions that rotated units out of the line, cavalry reconnaissance squadrons operated without pause. They screened advances, ran patrols, gathered intelligence, and fought wherever they were needed. The men came from industrial neighborhoods around Newark and nearby areas. Many had worked in factories, machine shops, and repair facilities before the war. They understood mechanical systems. They knew how to work with their hands. They knew how to improvise with limited resources. The Great Depression had taught them how to make do. The squadron had been attached to multiple divisions during the Normandy campaign, operating as a flexible core asset, shifting between units as required. By early July, they had supported the 2nd, 4th, and 9th Infantry Divisions. They had fought inland from Omaha Beach through the Bocage. They had lost men and vehicles. They had seen firsthand what the hedgerows did to American armor and infantry. The problem was not ignorance. Tankers knew exactly what doctrine required. Every briefing emphasized proper crossing techniques. Every training session drilled coordination with engineers. The doctrine was clear. The problem was that combat in the Bocage did not follow doctrine. Every field was different. Every hedgerow was unique. The Germans adapted faster than American doctrine could evolve. Curtis Cullen had been in France for 5 weeks. He was 29 years old, a Depression-era kid from New Jersey who had joined the National Guard before the war. He had worked on cars and trucks since he was 16. He understood how machines functioned. He knew how to improvise under constraints. His squadron included men with similar backgrounds: factory workers, machinists, welders. Together, they began developing ideas. The concept that emerged was straightforward. Instead of climbing over hedgerows, tanks could cut directly through them at ground level. The tank needed a way to concentrate force at the base of the hedge. Steel prongs or teeth that could bite into the earth and embankment. The weight of the tank would drive the prongs forward. The vegetation above would collapse. The hedge would split apart. The raw materials were everywhere. The beaches were still littered with German obstacles, Czech hedgehogs, steel barriers designed to rip open the hulls of landing craft. Each hedgehog consisted of 3 steel I-beams welded together in an X shape. The beams were high-grade steel, about 5 feet long, already cut and angled. Thousands of them lay scattered across the invasion beaches. Cullen went to the beach the following morning. He located a salvage pile near Vierville-sur-Mer, Czech hedgehogs stacked nearly 20 feet high. He selected one intact obstacle, cut it apart with a borrowed torch, and loaded 4 I-beam sections onto a truck. Total time, 45 minutes. No one questioned him. Salvage operations were constant. He returned the beams to the maintenance area and spent the rest of the day measuring and planning. Each beam needed to be roughly 4 feet long to provide sufficient penetration. The ends had to be cut at an angle and sharpened to focus force. The prongs had to be spaced wide enough to split the hedge mass but close enough to prevent the tank from bottoming out between them. Welding began after midnight on July 9th. The maintenance area was quiet. Most of the unit slept. The only sounds were generators humming and distant artillery. Cullen worked alone beneath a tarpaulin to conceal the light from his welding torch. He positioned the first beam against the lower front hull of the Sherman, angled slightly downward. It had to be welded directly to the transmission housing for maximum strength. He tacked it in place, checked the alignment, then laid a full weld bead. The steel was thick. The weld had to be flawless. He worked methodically, ensuring every joint was complete. His hands were steady despite having already worked a full maintenance shift that day. The second beam went on the opposite side. Symmetry was essential. Uneven prongs would cause the tank to veer during a breach. He measured twice and welded once. The third and fourth beams were mounted in the center, spaced 18 inches apart. By 0300 hours, all 4 prongs were secured. The modification added roughly 300 pounds to the front of the tank. The steel teeth extended 42 inches from the hull, angled downward at 20 degrees. Cullen stepped back and examined his work. The Sherman looked unusual, almost predatory. The 4 steel prongs gave it the appearance of a mechanical animal. Other tankers would probably laugh. Officers would certainly ask questions. But if it worked, if it allowed the Sherman to cut through hedgerows without exposing its belly armor, then regulations could wait. He cleaned the area, concealed the welding equipment, and walked back to his tent at 0400. He did not sleep. He lay on his bunk watching the canvas ceiling and thinking about what would happen if the modification failed, if the welds broke during impact, if the prongs bent, if the tank flipped over, if soldiers died because of something he built without authorization. But if he did nothing, soldiers would definitely die. That was not a possibility. That was a certainty. The hedgerows were killing Americans every single day. At 6:30, Cullen walked to the motor pool and found Captain James Dew, one of the squadron officers. He told Depew about the modification, showed him the welded prongs, explained the concept. Depew listened without interrupting. When Cullen finished, Depew said they needed to test it before anyone from battalion saw it. If it worked, they could show senior command. If it failed, they would remove the prongs and reconsider the approach. They drove the modified Sherman to an abandoned field behind the American lines at 0900. There was a hedgerow there. Typical Norman. Construction. Approximately 4 feet of earthen berm topped with 10 feet of dense brush and small trees. No Germans, no observers, just Cullen, Deep, and the tank crew. Kulan climbed into the driver's position. DW stood outside to observe. Kulan started the engine, engaged the transmission, and drove toward the hedgerow at 10 miles per hour. The steel prongs hit the base of the hedgerow. There was a tremendous impact. The tank shuddered. For a moment, Cullen thought the welds had failed, but the Sherman kept moving forward. The prongs bit into the packed earth. The tank's 30 tons of weight drove them deeper. The hedgerow split apart. Dirt exploded outward. Vegetation collapsed across the tank's hull. The Sherman burst through to the other side in 4 seconds. All 4 tracks stayed level. The belly armor never exposed. The main gun stayed on target. A deputy was calling out observations. Cullen could barely hear him over the engine noise. He reversed back through the gap, shut down the engine, and climbed out. Deputy was examining the breach. The hedgerow had a ragged hole torn through it at ground level, approximately 8 feet wide. Clean breach, no explosives, no exposed belly, no vulnerable moment. Deepu said they needed to show this to senior officers who could authorize wider adoption. What neither Cullen nor his fellow squadron members realized was that word was already spreading. Other tank crews had watched tests of modified Shermans cutting through hedge. They saw tanks breaching at ground level without exposing belly armor. They saw a solution to the problem that had been killing them for 6 weeks. Tankers from other units started asking about the modifications. Some battalion commanders refused. The modifications were unauthorized. They violated Army regulations regarding vehicle alterations. Installing them could void warranties and create liability issues. Other commanders looked at their casualty reports and decided regulations could wait. Mechanics from other units learned the technique. They found Czech hedgehogs on the beaches, cut the beams to 4 foot lengths, sharpened the ends at angles, positioned them on front holes low enough to strike hedge bases, spaced them to divide mass evenly, welded them solid with full penetration welds. The modifications spread through informal networks. A tank commander would see a modified Sherman and ask where it got the attachment. The crew would point to their motor pool. The tank commander would talk to his mechanics. The mechanics would find someone who knew the technique. By mid-July, mechanics in multiple battalions were installing hedgerow cutters. By July 13, Cullen had modified 9 tanks. Word spread through the division faster than anyone expected. Tank commanders who had lost crews in the hedge heard about the modifications from mechanics in the motor pool. Platoon leaders who watched their Shermans burn after exposing belly armor started asking questions. Where could they get the steel prongs? Who knew how to install them? How long did it take? Some battalion commanders refused outright. The modifications were unauthorized. They violated Army regulations regarding vehicle alterations. They had not been tested by ordnance. They had not been approved by Tank Destroyer Command. Installing them could void the Sherman's warranty, create liability issues, and result in disciplinary action if something went wrong. Other commanders looked at their casualty reports and decided regulations could wait. They had lost 30% of their armor strength in 3 weeks. Crews were refusing to cross hedge rows without engineer support. Engineer casualties were approaching 50% because German artillery targeted every demolition team. Something had to change. Cullen showed mechanics from other units how to do the work. He walked them through the entire process. Find salvaged Czech hedgehogs on the beaches. Cut the I-beams to approximately 4T length. Sharpen the ends at a 30 degrees angle. Position them on the front hull low, enough to strike the hedgerow base. Space them to divide the mass evenly. Weld them solid, not just tack welds. Full penetration welds that would hold under impact. Test the welds before declaring the job complete. The mechanics learned quickly. Most were experienced welders who had worked in factories or repair shops before the war. They understood structural loads and stress points. They knew how to make field repairs that would hold under combat conditions. Within 2 days, mechanics in 3 different battalions were installing hedgerow cutters on their units' tanks. The modifications spread crew to crew and unit to unit through informal networks. A tank commander would see a modified Sherman cut through a hydro and ask where it got the attachment. The crew would point to their unit's motor pool. The tank commander would talk to his mechanics. The mechanics would talk to Cullen or one of the other soldiers who had learned the technique. By mid-July, the knowledge was spreading faster than official communications could track. No official documentation existed, no engineering drawings, no approved specifications, no installation procedures, just soldiers teaching other soldiers how to weld German scrap metal to American tanks because it worked. And the official solutions were getting people killed. Some mechanics made subtle variations, 5 prongs instead of 4. Different angles, longer or shorter lengths. Each crew tested their own modifications and adjusted based on results. On July 14, word reached Division Headquarters. An inspection officer noticed several tanks in the 2nd Armored Division had unauthorized modifications on their front hulls. He reported it up the chain instead of ordering the modifications removed. Division Commander Major General Edward Brooks requested a demonstration. General Omar Bradley was visiting 2nd Armored Division that day as part of pre-mission planning for Operation Cobra, the planned breakout offensive, scheduled for late July. Brooks asked Bradley if he had time to see something interesting. Bradley agreed. They drove to a training area near Columbiers where Carl Sherman was waiting. Bradley arrived at 07:30 hours. He saw the modified tank with its 4 steel prongs and asked what he was looking at. Cullen explained the modification. Bradley listened and then asked for a demonstration. Cullen climbed into the driver's seat. His crew mounted up. The tank backed away from a hedgerow approximately 50 yards. Bradley stood with Brooks and several staff officers. Cullen engaged the transmission and accelerated toward the hydro. The Sherman reached 10 miles per hour. The steel prongs hit the earth and burned. The hedgerow exploded. Dirt and vegetation erupted outward. The tank burst through under a canopy of falling debris. 4 seconds. Clean breach. The Sherman emerged on the other side with all systems operational. Bradley stood there for a moment, not saying anything. Then he walked to the gap and looked at the torn hedgerow. The breach was approximately 8 feet wide, ragged edges, base torn out at ground level. He asked Cullen how long it took to install the modification. Cullen said approximately 6 hours per tank if the welder knew what they were doing. Bradley asked if the materials were available. Cullen said the beaches were covered with German obstacles, enough steel to modify hundreds of tanks. Bradley turned to his staff and said to get every ordnance unit in 1st Army working on this immediately. He wanted as many tanks as possible modified before Operation Cobra. The attack was scheduled for July 25. That gave them 11 days. Bradley ordered Lieutenant Colonel John Madaras from Ordnance to coordinate production. Madaras was told to use every welder, every maintenance unit, every salvage team available. 3 out of every 5 tanks in 1st Army needed these modifications before the offensive started. Cullen stood there watching generals and colonels discuss his unauthorized modification like it was official policy. Nobody mentioned court martial. Nobody talked about regulations. They were talking about production schedules and welding crew assignments. For his work, Cullen was recommended for the Legion of Merit. 3 other men from the 102nd Cavalry also received the Legion of Merit for their roles in developing and manufacturing the hydrocutter. Major Arthur Son and Captain James Depew, the squadron's senior officers who supported the unauthorized project. Captain Stephen Linton, who helped refine the design. Cullen was the sergeant who built the prototype. But the final device was a collaborative effort. The official recognition understated the grassroots nature of the invention. Bronze stars went to the tank drivers who tested the early prototypes under fire. Technical Sergeant Harmon McNorton, Private John Huey. Bronze stars also went to the welders who manufactured hundreds of devices in field workshops. Technical Sergeant Wesley Witt, Technical Sergeant John Jessen, Technical Sergeant Ernest R. Castle. These were the men who turned one experimental attachment into an Army-wide modification in less than 2 weeks. Over the next 11 days, American ordnance units worked around the clock manufacturing hedge cutting devices. Bradley had ordered Lieutenant Colonel John Madaras from Ordnance to coordinate production. Madaras established manufacturing priorities immediately. Every ordnance unit in 1st Army was assigned quotas. Welding crews worked in shifts, salvage teams stripped Czech hedgehogs from the beaches faster than they had been removing them. The devices were called rhino attachments. Some called them kin cutters. Each device was slightly different because they were handmade in field workshops, but the basic design remained consistent. For steel prongs welded to the front hull, cut from German beach obstacles, angled downward 20 to 30 degrees, strong enough to split a hedgerow, spaced to divide the mass evenly. The work required skilled welders. These were not simple tack welds. The prongs had to withstand tremendous impact forces. Full penetration welds were essential. The steel had to be fused to the whole structure so it would not tear away on first contact. The men who did this work were experienced craftsmen. Technical Sergeant Wesley Witt had been a welder in civilian life. Technical Sergeant John Jessen had worked in a shipyard. Technical Sergeant Ernest Hardcastle had maintained industrial equipment. These were the men who turned one experimental prototype into hundreds of combat-ready modifications. The tank drivers who tested the first devices also received recognition. Technical Sergeant Harmon McNorton drove one of the first modified Shermans through a hedgerow under fire. Private John Huey tested another early model during combat operations near St. Lo. Both men received Bronze Stars for their role in proving the concept worked under actual combat conditions. By July 24, approximately 500 tanks in 1st Army had been modified. Shermans, Stuarts, even some M10 tank destroyers. The modifications covered approximately 60% of the armor going into Operation Cobra. Some units had modified nearly all their tanks. Other units had only a handful. The capability was spreading faster than official channels could have approved. Then the Germans noticed something had changed. German infantry first reported unusual American tank activity. In late July, forward observers noted that American tanks in some sectors were no longer always climbing over hedge rows. In certain engagements, tanks were cutting through at ground level. The reports were filed, but initially received limited attention. American tactics changed frequently as units learned and adapted. By late July, patterns emerged. German anti-tank crews reported that tactics, which had worked reliably, were failing more often. They would position guns to cover hedge crossing points where American tanks typically exposed their belly armor during climbs. But increasing numbers of American tanks were breaching at ground level with frontal armor protected. Guns positioned for high-angle belly shots found themselves engaging frontal armor instead. Similar reports came from German positions across the front. American tanks were breaching hedge rows in seconds without exposing vulnerable points in ways that had not been common earlier in the campaign. Tactics that had worked for 6 weeks were succeeding less consistently. German anti-tank crews were losing their predictable advantage. Senior German officers tried to understand what had changed. They examined wrecked American tanks looking for modifications. What they found were crude steel prongs welded to the front hulls. The purpose was not immediately obvious. The steel looked like salvaged beach obstacles. Some officers thought it was improvised armor. Others thought it was designed to trigger mines before the tank's main hull reached them. Few understood it was specifically designed to exploit the hedgerow's construction. By late July, German defensive plans started adjusting. Anti-tank guns that had been positioned to fire at hedgerow crossing points were being moved. Units that had relied on the bowage to channel American tanks into kill zones were being repositioned. The hedgerows were no longer reliable obstacles. The psychological impact on German defenders was significant. For 6 weeks, the bowage had been their greatest asset. Every hedge was a defensive position. Every field was a strong point. The terrain did most of the work of stopping American armor. German infantry could fight from prepared positions and let the hedge do the killing. That advantage was gone. American tanks were cutting through hedge faster than German infantry could reposition. Defensive plans that depended on controlling specific gaps were useless when the Americans could make their own gaps anywhere they wanted. Units that tried to use old tactics found themselves being outflanked by Shermans that appeared from unexpected directions. Some German commanders tried to adapt by thickening their hydro defenses. Additional obstacles, more mines, deeper fighting positions. But obstacles that stopped a climbing tank did not stop a tank cutting through at ground level. The modifications did not care about additional barriers. They cut through everything. Operation Cobra launched on July 25, 1944. The offensive began with a massive aerial bombardment. Over 1,500 heavy bombers and 350 medium bombers dropped more than 4,000 tons of bombs on German positions south of St. Lo. The bombardment was meant to shatter German defenses and open a corridor for American armor to exploit. The first day results were mixed. The bombing had been partially effective, but also caused significant American casualties from short drops. Ground forces advanced but encountered stiff German resistance in many sectors. The hedge still channeled movement. German defensive positions still took advantage of every piece of terrain. But tanks equipped with hydro cutters made a difference. They could breach at unexpected points. They could create their own gaps instead of using predictable crossing points. They could support infantry advances without waiting for engineers to blow paths through every hydro. The tactical flexibility was significant even if the devices did not revolutionize the battle overnight. The First Army advanced 7 miles. On the first day, 12 miles by the second day. German defensive lines that should have held for days were overrun in hours. By July 28, American forces had achieved a breakthrough. German units were withdrawing. The WWII stalemate was over. By July 31, the breakout was complete. American armor was in open country beyond the WWII. Third Army, under General Patton, passed through this gap and began its rapid advance across France. The hedgerows that had protected German defenders for 6 weeks were behind the advancing American forces. The hydro cutters played a supporting role in this success. Historians debate their tactical importance. Some argue they were psychologically significant, boosting morale and giving tankers confidence. Others argue the devices had limited practical effect since armor primarily advanced on roads during the breakout rather than cross-country. The truth likely falls somewhere between. The modifications helped in specific tactical situations and contributed to overall combat effectiveness without being the single decisive factor. German commanders filed reports trying to explain how American forces had achieved such rapid breakthrough. Most cited overwhelming firepower and air superiority. Some mentioned new tank tactics. Few understood that the breakthrough started with scrap steel welded to tank holes by soldiers who did not wait for permission. The modification was never officially credited to any engineering department or design bureau. After the war, American armor development reports mentioned hydro cutting attachments as field expedient modifications developed in theater. Curtis Cullen's name appeared in some unit histories, but not in official Army documentation. Cohen did not receive public recognition during the war. He was awarded the Legion of Merit in September 1944 for exceptional service. The citation mentioned his contribution to armored operations in Normandy, but did not specify the hedge cutter invention. 4 months after the demonstration for General Bradley, Cullen was wounded by a German landmine in the Herkin forest. The explosion severed his left leg below the knee. He was evacuated to a field hospital, then to England, then back to the United States. His war was over. He spent 6 months recovering at an army hospital in New Jersey. Physical therapy, learning to walk with a prosthetic leg, adjusting to the reality that his tanker days were finished. He was discharged from the army in March 1945 with a Purple Heart and a medical retirement. Cullen married Bernice Enright in June 1945. They settled in New York City. He took a job as a salesman for Schenley Industries, a liquor distributor. This kind of swift decision-making, bypassing conventional bureaucratic procedures when speed was essential, played a critical role in American success in Normandy. This is how innovation truly occurs in war, not through official channels or engineering committees, but through mechanics and tank crews collaborating to solve problems. Through soldiers welding scrap steel to tanks because it worked. Through crews testing prototypes under combat conditions. Through junior officers and senior enlisted men willing to flout regulations when lives were on the line. Curtis Cullen received the most public acclaim, but the hedge cutter was the product of many hands. The welders who produced hundreds of devices in field workshops, the tank drivers who tested early models, the officers who supported the unauthorized project, and the mechanics who disseminated the technique across multiple units. Every one of them contributed to a battlefield innovation that altered the course of the Normandy campaign. Curtis Cullen was not supposed to modify his tank. He was unauthorized to weld German steel onto Army equipment. He had no clearance to alter his vehicle's operational characteristics. Regulations existed for valid reasons. Unauthorized modifications could jeopardize safety. Unproven changes could trigger equipment failures. Field mechanics lacked the formal engineering knowledge to assess structural loads and stress factors that professional designers considered. Yet Cullen did it anyway because official solutions were too slow and soldiers were dying. This tension between adhering to protocol and taking immediate action to preserve lives defines many military innovations. Sometimes the rulebook provides the answer. Sometimes survival demands writing a new one. The hedge cutter story became embedded in American military culture. Officers at command and staff colleges study it as an example of tactical innovation under pressure. The case highlights how frontline units adapt to unanticipated battlefield conditions, illustrating the value of decentralized initiative and empowering junior leaders to solve critical problems. Yet popular accounts often oversimplify the story, crediting a single brilliant sergeant with saving the Normandy campaign. The reality was far more collaborative. Several units developed hedge-breaching devices simultaneously. The 79th Infantry Division had operational cutters by early July, the 19th Corps experimented with prong devices, and the 5th Corps created their own versions. Cullen's contribution stood out because senior commanders witnessed his demonstration and decided to scale it across the Army. The 4 men from the 102nd Cavalry awarded Legion of Merit medals, Major Arthur Son, Captain James Dew, Captain Stephen Linton, and Sergeant Curtis Cullen, represented a team effort. The welders, Wesley Witt, John Jessen, and Ernest Hardcastle, translated the concept into mass production. Tank drivers Harmon McNorton and John Huey proved the devices worked in combat. Each contributed essential elements to the success. Decades later, military analysts reviewing the Normandy campaign recognized the hedge cutter as one of several crucial tactical innovations that enabled the Allied breakout, not a single decisive weapon that won the battle, but an important factor among many that collectively overcame the Bocage stalemate. The Czech hedgehogs providing raw materials had been emplaced on Normandy's beaches by Field Marshal Owen Rommel's engineers, forming part of the Atlantic Wall defenses intended to destroy Allied landing craft. American mechanics transformed these obstacles into tools that breached German defenses. They dismantled Rommel's beach fortifications and welded the pieces to tanks to penetrate the hedgerows. The irony was not lost. German engineers had constructed elaborate defenses to protect Fortress Europe, only for American sergeants to recycle their steel into instruments that dismantled it. Such tactical and material improvisation typified the American approach during World War II. The United States entered the conflict with less combat experience than its adversaries, having not fought a major war since 1918. Equipment and doctrine often proved inadequate for actual battle conditions. Yet American units adapted rapidly. Frontline soldiers identified problems, mechanics and engineers developed solutions, and officers willing to embrace unauthorized innovations granted tactical advantages. The hedge cutter exemplifies this broader pattern. American forces did not always possess superior equipment or tactics, but they consistently demonstrated the ability to learn, adapt, and implement changes faster than enemy forces could respond. That adaptability, more than any single weapon or tactic, contributed decisively to Allied victory. In Colombier, Normandy, near the location where General Bradley observed the first demonstration in July 1944, a small museum commemorates the liberation. It displays artifacts from the campaign, photographs of soldiers, and combat equipment. Among the exhibits is a section of steel from a Czech hedgehog, identified as scrap from German beach obstacles repurposed by American forces to overcome the hedgerow problem. Visitors photograph it during summer tours, often unaware that pieces of steel like this, salvaged from invasion beaches and welded onto tanks by soldiers working through the night, altered tactical options during a pivotal stage of the Normandy campaign. The museum also showcases photographs of Sherman tanks with the distinctive four-prong front attachments, showing tanks cutting through hedgerows as dirt and vegetation erupted outward, a breakthrough that seemed impossible in early July. Veterans visiting sometimes point out specific details, recalling particular fields and moments when the modifications made the difference between survival and death. The modification succeeded because Curtis Cullen and his fellow mechanics understood that complex challenges sometimes have simple solutions if one is willing to disregard rules long enough to test an idea. The Army spent weeks attempting to solve the hedgerow problem through formal channels. Engineers tested explosives, ordnance officers evaluated bulldozer attachments, commanders revised tactical doctrine, but none of it worked effectively. The solution came from soldiers who seized German scrap metal and began welding. If you found this story compelling, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters. Each one deserves to be remembered. Leave a comment telling us where you're watching from. Our community spans from Texas to Tasmania. From veterans to history enthusiasts, you are part of something special here. Thank you for watching, and thank you for keeping these stories alive. The work was different from anything he had done before. No more tanks, no more maintenance, no more welding German scrap metal in the dark, just sales, calls and client meetings and trying to build a normal life. He did not talk much about the war. When people asked, he would say he worked on tanks in Normandy, fixed engines, maintained equipment. That was all. He never mentioned the hedgerow cutters unless someone specifically asked. Even then, he kept it brief. It was just something that needed doing. He emphasized the collaborative work the other men from the squadron who built and tested the devices. Veterans of the 102nd Cavalry kept in touch after the war. They formed an association, held reunions, maintained the history of their unit. The hedgerow cutter remained a source of pride. The squadron's official history documented how enlisted mechanics and officers worked together to develop a battlefield innovation that senior command quickly adopted. General Bradley mentioned the hedger cutter in his memoir, A Solder's Story, published in 1951. He described watching the demonstration and realizing that sergeants and mechanics had solved a problem that had stalled First Army for weeks. Bradley wrote that the device was so absurdly simple it had baffled an army for more than 5 weeks. He credited Curtis Cullen by name, though he incorrectly listed him as Curtis G. Cullen Jr. rather than the third. President Dwight Eisenhower mentioned Cullen in one of his last speeches as president in January 1961. Speaking to the American Society of Mechanical Engineers, Eisenhower told the story of a sergeant who had an idea about putting knives on tanks to cut through hedgerows. Eisenhower said the idea went from captain to major to colonel until it reached General Bradley, and Bradley acted on it immediately. Eisenhower used the story to illustrate that innovation in wartime comes from soldiers in the field, not from headquarters. Eisenhower repeated the story in 1964 during a CBS interview with Walter Cronkite. The interview was filmed in Normandy on the 20th anniversary of D-Day. They stood near a hedge. Eisenhower described how the bowage had nearly stopped the American advance and how one sergeant's improvised solution changed everything. He said the invention gave the Army back its mobility and made Operation Cobra possible. Curtis Cullen never saw most of this recognition. He lived quietly in New York City working as a salesman. He and Bernice divorced in the early 1950s. He continued working for Shinley Industries. He walked with a prosthetic leg and rarely mentioned his military service. In 1963, Curtis Cullen died of a heart attack in Greenwich Village. He was 48 years old. His obituary in the New York Times mentioned his service in World War II as a tank sergeant. It mentioned the Legion of Merit. It did not mention the hedgerow cutter. It did not mention that his modification helped break the stalemate in Normandy. It did not mention that he violated regulations to save lives. There is a memorial to Curtis Cullen in his hometown of Cranford, New Jersey. A bronze plaque mounted on a boulder outside the municipal building on North Union Avenue. The plaque includes Eisenhower's quote about the sergeant who had an idea. A street in Cranford was also named Cullen Drive in his honor. Residents walk past the memorial daily. Most do not know the full story. Most do not know that the modification was initially unauthorized. Most do not know about the other men from the 102nd Cavalry who contributed to the Invention. In 1998, a military historian researching Operation Cobra found references to hedge-cutting modifications in 2nd Armored Division maintenance logs and 102nd Cavalry Squadron records. The historian tracked down surviving members of Cullen's unit through veteran registries. Several remembered Cullen. They remembered the modified tanks. They remembered the demonstration for General Bradley. They remembered that the modifications spread through multiple units in less than 2 weeks through informal soldier networks. The historian estimated that the hedgerow cutters contributed to reducing American tank casualties in the Bocage. Though precisely quantifying the impact remained difficult, the devices changed tactical options available to tank commanders. Instead of exposing belly armor during every hedgerow crossing, tanks could breach at ground level with frontal armor protected. Instead of waiting for engineers to blow gaps, armor could create breaches on demand. Instead of predictable crossing points that German gunners could cover, American forces could attack from varied directions. Post-war analysis by the United States Army Center of Military History examined the Normandy campaign in detail. The studies concluded that multiple factors contributed to the eventual breakout from the Bocage: overwhelming Allied air superiority, superior numbers of tanks and artillery, better logistics, improved combined arms, coordination between infantry, armor, and engineers. The hedgerow cutters were one tactical innovation among many that collectively enabled Operation Cobra's success. Military historians continue to debate the hedgerow cutter's significance. Some emphasize its psychological importance. The modifications boosted morale among tankers who felt they finally had a tool to deal with the bouquet. Knowing they could cut through hedgerows without exposing vulnerable bellies gave crews confidence to push forward more aggressively. Other historians emphasize tactical flexibility. Even if tanks often advanced on roads during the breakout rather than cross-country, the option to breach hedgerows at unexpected points forced German defenders to spread their limited anti-tank assets more thinly. German units could no longer concentrate defenses at a few predictable crossing points. Still, other analysts argue the devices had limited practical effect. Most armored advances during Operation Cobra followed roads and existing gaps, rather than cutting through hedge systematically. The massive aerial bombardment and overwhelming force concentration mattered more than any single tactical modification. The hedgerow cutters helped at the margins, but did not fundamentally change the battle's outcome. The truth likely encompasses all these perspectives. The hedgerow cutters were neither the decisive war-winning innovation that some popular accounts suggest, nor were they militarily insignificant. They represented an important example of how frontline soldiers identify problems and develop practical solutions faster than official channels. They demonstrated that tactical innovation often emerges from the bottom up rather than top down. The story also illustrates organizational dynamics in military forces. The 102nd Cavalry developed the modification outside official channels because official channels moved too slowly. Ordnance was studying the hedge problem. Engineers were experimenting with demolition techniques, but none of these official efforts produced a solution that could be deployed widely or quickly enough to aid the units engaged in combat in early July. The soldiers improvised what they required using materials at hand. General Bradley's decision to endorse and rapidly expand an unauthorized modification demonstrated remarkable leadership flexibility. He could have ordered the devices removed for breaching regulations. He could have demanded formal testing and engineering approval. Instead, he recognized a practical solution and mobilized Army resources to fabricate hundreds of devices in under 2 weeks.